last question. It says, Animal plans to buy a house 4 years from now. So, he, in order to save for the $30,000 down payment of the house, he decides to make equal monthly payments at the end of each month in a savings account that pays 5.5% per annum, compounded monthly. And then it says, determine what animal's regular deposit should be in order for him to make the down payment immediately after his last deposit. So some of the words here might seem a little bit confusing, but basically the gist of the problem is he wants to have $30,000 as a down payment for a house. He's going to be making regular payments, regular monthly payments, so that he can try to have the $30,000 so that he can put the down payment down for his house. Okay, so is this a compound interest problem or is it an annuities problem? Well, let's take a look. Is he making regular payments? If he's making regular payments, then it makes it an annuity. So let's read the question again. Animal plans to buy a house 4 years from now. To save for the $30,000 down payment, he decides to make equal monthly payments at the end of each month. So he is putting in equal monthly payments. At the end of each month, he's putting in the same amount of money so that by the end of the 4 years that he invests, he has $30,000. So his goal is to have $30,000 saved up in an account 4 years from now so that he can pay for his down payment of the house. So because he's making equal monthly deposits, that means that this is definitely an annuity problem. Okay? So let's start by writing the future value of an annuity formula. And I know it's a future value because he's putting in small amounts of money now so that he has a large amount of money that he can use in the future. So start with the formula. Okay, and let's see what information we know. First of all, we know that he wants to have $30,000 in the future. So that is not his regular payment. If it was, that would be pretty amazing. So you can make regular payments of $30,000. That's quite a bit of money. But what that $30,000 actually represents is the accumulated amount. So this is the amount of money he wants to have in the future. It's not R, it's actually A. Okay, we know the interest rate per compounding, we know the interest rate, but we know it's also compounded monthly, so we can figure out what I is. We can also figure out the number of payments or the number of compounding periods, and that's just 12 times a year for 4 years, so we can calculate that. So then what are we actually solving for? We are actually looking for what his regular deposits should be so that he actually has that amount of money that he wants to have in the 4 years. So we're actually solving for R. So we know that A is equal to 30,000. We don't know what R is equal to. That's actually what we're solving for. We know I is equal to 0.055, so 5.5%. And it's compounded monthly, so I need to divide it by 12 to figure out the interest rate per compounding period. So 0.055 divided by 12. It's a bit of a messy number, so 0.004583333, so that continues. And then the number of payment periods or the number of compounding periods, well, he's making payments at the end of each month, so that's 12 payments in a year. And he's making payments for 4 years. So that means in total he's going to be making 48 payments. Okay, so now we have all the information we need. Now, because I'm solving for R, what I'm going to do first is rearrange the equation that I'm given so that I can isolate R. What that'll help me do is substitute in all the information on one side, and then I can do all my calculations in one step instead of rounding off and making any calculation errors. So I'm going to rearrange the equation first. So in order to get R by itself, I need to multiply both sides by I. So I get AI equals R times 1 plus I to the exponent n minus 1. And to get R by itself, I need to divide both sides by 1 plus I to the exponent n minus 1. So I'll do that to both sides. And so you'll notice that on the right-hand side, these two cancel and you're left with just R. And on the left-hand side, I can actually substitute in all the information that I know. So A is 30,000 0.004583 continued. And in the denominator I have bracket 1 plus I, so 1.004583 continued minus 1, and the exponent I have on the 1 plus I value is 48. So this looks a little bit messy, but I'm pretty sure we can do it all in one step on the calculator. So if I type this into the calculator, I get 30,000 times 0.00458. Because the 3's continued, I'm going to add as many 3's as I can on my calculator. And so that's the value of the numerator divided by brackets. Don't forget to put brackets because you have more than one term in the denominator that you're going to be dividing with. 1.00458. Put as many 3's as you can to the exponent, 48, minus 1, closing bracket. So that's the value of the denominator. And now if I press equals, the numerator and denominator will divide, and I'll get about $560.19. Okay, remember these are all examples with money, so you want to make sure you have 2 decimal places. Okay, so therefore, animals should make regular payments of $560.19. And again, if you want to figure out how much interest he's earned, you can figure out how much he's actually put into an account and then subtract that from the total amount that he would have. So if you think about his payments, so if we're trying to figure out how much interest he's actually earning, in terms of his payments, he's actually making 48 payments of $560.19. So if we figure out what that is on the calculator, he's actually only putting in $26,889.12. The amount of interest he would be earning would be the difference between $30,000, which is his accumulated amount, and the amount of money he's actually put into the account. And so the amount of interest he's actually earning in this account over the span of those 4 years is $3,110.88, which is not so bad. Okay, so that's pretty much it. Here's your assigned work from your textbook, and don't forget to watch the video on the last lesson of the course, which is on present value of an annuity.